this is just a basic demonstration of Vextra. So the data set that we're using here for demonstration is from wonder.cdc.gov, the underlying cause of death data set from 1999 to 2020, aggregated by year, age group, sex, race, and injury intent as cause of death. Down here you can kind of see data set preview, right? So these injury intents are things like suicide, undetermined, legal intervention, non-injury or no intent classified, and this is all by age group, sex, race. And then we've also got the accrued rate as well as a actual death count unless suppressed. So getting into the functionality. What's happening here is you're able to type in a search. Okay, so we'll go ahead and just use one of our examples here. So how do homicide rates compare between males and females? Once you click ask, what'll happen is using Vertex AI and a text embedding model, we will take this search, vectorize it, and then we will search MongoDB and find for similarities. If we come up with a match that is 99% or more similar, then we will take the data stored in the database and show it to the user. So we'll go ahead and ask here. And because this was found in the database, it will spit out our base64 encoded image that was stored in the database. And so yeah, so here we can see this bottom line. Here's female, upper line here is male. So we can see that the homicide rates of males is much, much higher. And then we also have a text analysis, and it lets us know that this source was retrieved from our knowledge base based on a 100% match. Down here, we've got some searches that are closely related to this. So basically, whenever we're submitting this for similarity matching, it will also take results that are above 75% similar and spit them out here as well, just so that users can see related questions. And the reason that we did that is we really did want to showcase the beauty of vector stores and how they can be used for searching and indexing. Because while this search function does use it, relying on a 99% match obviously doesn't really showcase the usefulness of vectorization, and you may as well just search a database at that point, right? Because you're not actually really too worried about how the vectors compare to each other. So with this search function, we're actually able to show in a meaningful way how it can be used and how it can be used with a lower threshold so that things are less absolute and more fluid. Now, if we do our own question, what'll happen is it will, not find a match. It will then send the request. The Gemini 2.0 Flash model will generate some Python code, create a chart, and then using the data that was used to create the chart, we will send that back to Gemini 2.0 Flash, and it will generate a text analysis as well. So what we'll do here is we'll say how many white people died by homicide from 2005 to 2010. So we'll go ahead and ask that question here, and we'll take a second and think. All right, and so now we've got our chart. And so what we can see, we have our years lined out. We have 2005, 2006, 2007, 2008, 2009, and 2010. And we've got our deaths by homicide here. So honestly, it was pretty constant throughout those years. Let's see what Gen AI had to say based on the provided data. It goes through all of its logic here, how it found everything. It even gives us a total of all of the deaths, which was 51,587. And then for trends, the number of deaths appears to be relatively stable, which is true. And it does fluctuate slightly. There was a notable decrease, though, from 2009 and 2010. And 2010 had the lowest recorded within this time frame. So awesome, pretty good numbers. And then it lets us know that it was generated freshly based on their question. And again, we've got all of our fun little matches where we can see everything. So we could, pull up another one and get the data. But yeah.